I'm excited to learn more about what do you have on your T-shirt? To feed the soil and how that feeds the world.
Yeah, well, this is such a beautiful topic, and I'm so grateful that we're able to discuss it because to me, the more I learn about the soil ecosystem, the more excited I get about it. So my background is in agricultural science, and I ended up majoring in microbiology because I knew that microbes can literally clean up the mess we've made, pesticides, all kinds of chemical, nasty stuff, oil spills. And once I found that out, I was like, well, agriculture is really actually ridden with all kinds of chemical treatments that we apply to our soils and our animals and our plants. So what a wonderful way to get into this idea of using microbes to actually clean up the mess we've made and make and go back to the original way that it was designed to function. And those same organisms that do the cleanup are actually the organisms that feed the plants as well and provide immunity for plants, and they might vary, but that biodiversity around the root, all the fungi and bacteria particularly that are there, they literally take nutrients out of rock from the soil, from the mineral component of the soil, the sand, silt, and clay, and are able to take that into their bodies. And as other organisms munch on them and graze on these very, very nutrient-rich organisms, bacteria and fungi, they literally release fertilizer for the plant. They literally feed the plant. So without the first initial two organisms being present, that's the two major groups, the fungi and the bacteria. And without those guys being present in the first place, none of this can happen. So the plant can't actually be fed. And even in agricultural systems, when we apply fertilizers, those microbes are gone by then. And so the plant is almost force-fed these chemical substances, which are not good for our bodies. They're not good for the plant. This is where pests come in and disease, what we call pests and diseases. But these organisms are just there because the plant is unhealthy. But when we return the system back into the soil and allow this microbial biodiversity around our roots, these plants respond so well and they become so healthy and nutritious and they have so much vitality. And the microbes actually protect them. So no pests and diseases, what we call those things that eat our plants, they cannot even enter the situation. So it's like a win-all situation because we don't have to buy anything to put into the soil. The plants are thriving because they've got their friends on their roots that they normally would be with. And then we also have the side effects of that, as in water infiltration. So way less water has to be used. We've got organic matter being built. So we're sequestering carbon into the soil, particularly fungi are present. So there's just so many benefits in working with these microbial systems and putting them back into our soils because they're very much depleted, particularly the fungi and the graziers. Bacteria is always there, but once again, how much biodiversity do we have left? So if we can encourage people to create the microbial preparations in a specific way I can describe and enter that into our systems again, we can regenerate really quickly and get food back into our systems that is going to nourish us, nourish the soil, nourish the ecosystem, nourish the animals, the birds that then feed above in the food web. So, it's all of this beautiful beginnings that we're dealing with when we're talking about soil microbiology, plant microbiology.
So I'm excited to learn how to do it.
Yes. So one of my favorite things at the moment is I'm running a course called Soil Restoration Course. And so I'm putting all these creatures and their superpowers into each lesson. They're quite sciencey, getting people to understand exactly how it all fits together and how it works. And then at the end, or at the beginning and at the end, I show people how to actually create that. And one of my favorite methods of creating these ecosystems, these soil ready-made ecosystems that we can literally do it ourselves and create those. What I mean, we create them, we provide the food and the moisture and the conditions for them to thrive. And they come from all the food that we actually feed to the worms. But really what we're doing is feeding the microbial world, and the worms feed on the microbes and they poo out double the biodiversity of microbes through their own ecosystem in their own gut. So they sort of like keep churning and making better and better conglomerates of microbial communities basically coming together through this process of marrying the worms, the microbes, and the food we provide. So literally using our own waste. And my favorite system to do it in is not to disturb the worms, because oftentimes in our worm composting systems, they've been tiered up, like you can get from Bunnings or wherever, those worm farms that are divided into sections. The beauty of the system I'm talking about is where you don't disturb that top layer. You feed a lot of carbon in addition to your food, and then fungi can start coming back into the system. And worms love eating fungi, so they'll keep eating them and then pooping them out. And as this continues, the fungi munch on the carbon we add. And when this happens, we actually end up with a really microbially diverse and fungal rich compost, and we can harness it from the bottom of the system. So basically, it's called a continuous flow through worm farm. I call it the wheelie worm flow because it's created in a wheelie bin, and the 60 top centimeters of that bin is there for that cultivation of the microbes, the worms in the top layer, churning that food. The microbes then can, on the bottom where the worms no longer live, they keep churning that and keep making it into beautifully rich, wonderfully plant accessible, the best plant accessible food possible. And then you can harvest the compost that the worms and the microbes have made through these slats on the bottom. And you can just rake it up from the bottom. So you wait quite a long time because the fungi have to take a while to develop. So you can probably wait up to a year for this process to finish. But then you've got this amazing compost. And then you can put it in a bag and dislodge the microbes into water. And that will be like a liquid that's actually microbially rich, where you actually milk out the microbes, dislodge them into the liquid, and then you get a watering can and, put it around your plants or on the leaves of a plant that might be suffering. You can even spray it on leaves to protect your plant from any imbalance. So we never use worm tea or worm wee, and all these things that we call worm sort of good stuff is not really, it's just a leachate, that's just a misconception. And people use that, but they don't realize it's anaerobic and it's been sitting there sort of rotting. We need good stuff, good microbes. We want our plants to have oxygen-based microbiology around them, so that oxygen-based microbiology can create more oxygen space for the roots to grow in, because our plants are very much loving of oxygen as well, even though they produce it in their leaves and we breathe it in, and they love the carbon. They also need their roots to be in a very lovely, friendly place for them. And that means oxygen is present as well as moisture, and as well as all their friends on their roots, which are the fungi, the bacteria, and all the creatures that feed on the fungi and bacteria that are so dense with nutrients that when they consume them, they release all that beautiful fertilizer, the poo that they make, and the plants love it. And they get really, really healthy and are thankful for that food supply.
I saw your system. One of my permaculture students lives at Gympie, and he told me about your work, and I tracked you down through that. And he showed me the wheelie bin system. And you could tell me more if you feel there's more that people need to know.
When we work on the wheelie worm flow, we've got to make sure there's enough moisture. Usually what happens is it's more of a dry system, in the sense that on the bottom there's a draft going up, so you're going to be drying it. So the worm farm is locked up on the bottom, which means no vermin can get in, and pretty much organisms shouldn't get in there that way from the bottom. From the top, we've got the lid, and we've got a little screen to allow some air movement. So we still want aeration, and the worms are creating aeration as they're going through. At the same time, when your worm farm doesn't have enough moisture, for example, you start seeing other organisms live there because they love it. Like I've got loads of beautiful native cockroaches in my worm farm, millipedes, because I'm adding a lot of beautiful organic matter from the surrounding vegetation to increase that endemic microbial diversity, particularly fungi. So it's not a conventional system, because we're trying to get the fungi back into the soil, because the fungi sequester carbon and they do a lot of work that I'll talk about in a second. So we've got to make sure moisture is present. When moisture is present, things like ants can't live in it. So, for example, when we start noticing ants, it is a good indication that there's not enough moisture in our worm farm. So it's a good indicator. Once you start getting that balance right, the ants move out. They don't like being wet. They run away from rain, come into houses. And the same goes, for example, soldier fly larvae, black soldier fly larvae. When they come in, that's an indication we're overfeeding our worm farm, because they will start eating the really anaerobic bacteria, whereas worms don't love the anaerobic bacteria. They'll eat them and they'll digest them and they poop out the nutrients, but they prefer to eat fresh fungi and bacteria that are oxygen-based, Worms love oxygen, they breathe oxygen through their skin, so they need to move through a very aerobic system. So the soldier fly larvae come in to take away that gunky stuff that worms can't handle. So that's an indication that it's too wet. So you can either get ants or you can get black soldier fly larvae, and there's an imbalance. So it's a lovely ecosystem that shows us any imbalances that we can then change and improve. While those organisms are not harmful in there, they're just an indicator, and we know that we can change the conditions to get it into a more functional way that the system can work. So that's the two things that are really important to remember also, that our moisture content is important. And when you pick up your worm castings, they should be about 80% moisture. So if you were to squeeze them really hard, which I don't recommend because you might squash your worms and other creatures that are there, but a little bit of moisture should come out of your hand. And I'm still getting the balance right on my farm because my farm was designed in a sort of a wooden recycled system that I created a few years back. And I'm realizing now it was lacking moisture. So I've put them in the wheelie bin now, and we'll be monitoring that moisture more carefully and getting the worms happier in there. Because while there's all these other creatures, we also want the worms to thrive as well. So that's just two main things that are important. Oftentimes, what we do with our worm farms, and I've always been one of those people that just used a worm farm to get rid of my food waste, because food waste contributes to landfill production of, methane and carbon dioxide and other nasty things. So we can add those food scraps. And, most people know not to add onion and the garlic and the meat and the dairy. So you really just want to give fruit and veg scraps. You don't want to give citrus and things like that. So it's quite simple, but there is a list that the worms will prefer the foods that they'll eat, and some that if you put too much of, they might kill your worms. And it happens. As we learn these things. So then you want to add that. But what I've always missed out on was adding that carbon layer. So when I look under the microscope, because I do soil analysis and compost and vermicompost analysis, so to see whether all the food web organisms are present, the bacteria, the fungi in the right ratio, and the right predators. So when I do that, I can see that a system that's been set up with just food scraps, it will be very much just bacterial dominated. But fungi have been completely demolished in our soils. They've been wrecked because fungi grow in very long hyphae, which are their cells. And when you can actually see them sometimes growing through the soil, it's called mycelium when it's visible. That's multiple cells running together side by side, and you can see them. You can call it the mycelium if you've never heard of this expression, to remind you that it's mycelium you're seeing of fungal cells called hyphae working together. But because when we disturb soil ecosystems, these fungi get broken up. Particular fungi won't get in the worm farm, which are the symbiotic fungi on our root systems that only the plant can feed. No one else can really feed them. So they come up there, and then those fungi will get water and nutrients. And in our worm farm, we can create this beautiful ecosystem of getting more fungi, the fungi that decompose all the carbon that you're going to give it, be it leaf matter, some maybe sugarcane mulch, any mulches you can find, any leaves, just allowing that really lovely nature to balance the food we're adding. Because you've got the carbon and nitrogen, and if you've got that 50-50 in the worm farm, that's a very simple way of just going, okay, that's great. It's much more difficult to achieve that in a composting situation. That's why the worms are such a good medium, because they do the work, and we don't have to worry too much about being too scientific. We just got to know what to add and what not to add and keep the moisture content, and it's very nice and easy. And all we have to do is harvest. We don't have to separate the worms. They're living in the top 20 centimeters of the worm farm. The bottom is all for fungi to do their magic. And then you just take it out and apply that to your garden, however way you wish to do that. When you add that, you always, and as you know, in permaculture, we always go through these principles of feeding the soil, the organic matter. Organic matter is vital in any system. So when we take out organic matter through plowing and drying, and we kill all the microbes, especially the fungi, the system doesn't work because the plants are like, where are my friends? No one's feeding me anymore. Now these humans are giving me this junk food, and I'll eat it because I have to, because I've got nowhere else to go, nothing else to feed on. But if we can just reduce that and keep giving beautiful nature-based worm-made food, I think we can't go wrong. It's how it's always been before the Industrial Revolution, before we started using chemicals on our soils. And I think getting farmers back into that natural systems where they don't pay as much money, the microbes I like the livestock doing the job underground for them. It's a beautiful way of getting us back to nature and back to systems that function. That's why I feel passionate about the willy worm flow, because it's an easy system. Once you do it and once you set one up, it's the best, because you're not doing that disturbance. You're not like having to take the worms out and deal with the eggs, and you're not wanting to introduce the worms out of your worm farm into a natural ecosystem, because the worms we use are not native as well. And we don't know what native worms we have in our soil. And there are at least 1,500 species of worms we do have, but we won't know in our specific situation. But when we create that habitat, the worms will come back as well. You know, the natural endemic worms will come, and it's just such a beautiful, beautiful system. And I wanted to explain in this what the soil food web then is that we're creating the habitat for in the worm farm. So the plant gives, being the primary producer, it fixes carbon from our breath, takes in carbon dioxide, releases oxygen for us. And through photosynthesis, it will change that carbon into liquid sugar. And that sugar is what we feed on, what animals feed on, and what the microbes feed on. And as that sugar, liquid carbon, flows through to the root system, bacteria get attracted to that, and fungi love it as well. And they start communicating with the plant because they're feeding from the plant. And the plant and the microbes are so intelligent that the plant says, look, guys, this is what I need. I know what I need to grow. You go and get that for me. So the plant and the symbiotic fungi will literally ask specific microbes to do that for them. So it's such a beautiful communication system where the plant knows exactly what it needs. It knows what microbes will give it to them. It knows what type of sugars and amino acids and other things it feeds that particular microbe, and that particular microbe will go and get that food for the plant. And so the plant will only work with the microbes that it wants to work with, and the microbes that are attracted are only the ones that the plant selects. So, and the fungi as well. So it's such an incredible system.
About your course, this is a time to plug it. So, any details that you'd like to share?
This course is designed to cater to any soil situation, be it a mining site, being a big industrial agricultural system, or be it a small farmer or someone with a balcony. It applies to anyone that's interested in understanding how the system works, how the soil food web is so vital. All the organisms functioning with the plant, and the predators of fungi and bacteria, or the grazers, the nematodes and the protozoa. Like, there's so little knowledge of in an average person about these systems and how these microbial worlds are vital to our existence. And understanding them and how they feed onto each other and how we can ensure they exist there will solve so many issues in this world. And that's why I feel so passionate about introducing, I call them the superpowers of the superheroes of our future, which are the creatures, the soil superheroes, because they've got so many little superpowers. It's so hard to imagine how such a small microscopic creature can have incredible superpowers in what they do. For example, one amazing thing average person doesn't think about is how much power it takes to fix nitrogen. Like, for us to fix nitrogen and then sell it as a fertilizer, it's an extremely expensive process, extremely polluting, and only maybe 20% of that fertilizer actually goes to plants. The rest runs off into waterways and pollutes our oceans, kills our coral reef. Huge problems. But little bacteria have been doing that for millions of years, and they do it for free. And they use hardly any energy except the enzymes in their own bodies to do that conversion of the nitrogen from the atmosphere and breaking the triple bond in a nitrogen molecule. And they're able to break that without any necessity of what we put into that process. You know, we need a lot of power to generate that, power to break those bonds. And it's just super expensive. Lots of fossil fuels are being used in the process to do it. So microbes do that for free. We can just employ them and encourage them to grow. And they do it in little nodules, usually on the plant, you know, like the legumes do it. But there's very many bacterial species that can do that without the nodule. As long as the conditions in the soil are there for them to work, they will do that for us. So that removes the costs and removes the energy waste, and is just freely available for us to utilize that beautiful process that nature has done for billions of years potentially, you know. So yeah, very incredible. It's such an incredible system that the more I learn about it and the more I look at the scientific literature and how it all functions and get that out and put it in the course, the more excited I get. And I feel like those lessons are going to turn to more, because there's so much more research coming out all the time. And I want everyone to do the course because I feel like if people understand it and can fall in love and understand the system really well, they will not go wrong, and they will understand that they're feeding livestock for their plants, that it's not the plant they're actually feeding. It's literally the microbial world that they so start to appreciate on such a greater level. And I'd love to teach this to children at schools. We're doing a workshop this weekend on Friday, and I'll be showing children the microscopy of all the beautiful microbes. And I'll be showing them a little mini bin system so they can learn how to do it, and we'll put it together, construct it. So I'd love for this to go into schools, into universities. It's still not very known in Australia. In the US, it's much more prolific what people are learning this from Elaine Ingham, Dr. Elaine Ingham.
Yeah.
And I feel like we need an Australian version of that. And I guess that's where I've stepped in and gone, right, how can I deliver this amazing story, the soil story? It's just beautiful. And we can save the world because we can sequester all that carbon, not only feed people, so food security, biodiversity increase, and carbon sequestration in large amounts. Dr. Elaine Ingham has estimated that within 15 years, if all farmers turned into this microbial system farming with fungal dominance, we could sequester all of the carbon from the atmosphere to pre-industrial times. So let's do it. I hope that explains it in a nutshell.
Yes, thank you so much.